Alright, 16. Find the mean, median, and mode for these. So the mean, so we've got a sample, so x bar, of course, is going to be just adding them up. 282 plus 270 plus 260 plus 266 plus 257 plus 260 plus 267 divided by 7 flights, 7 total. So that's going to be 266. This is a flight time in minutes. So that's your average. The median, so we have to write from smallest to largest. So smallest is going to be 257. We got 260, 260, 266, 267, 270, 282. There's 7 pieces of data, so that's going to be my middle piece of data. So the median, m equals 266. And the mode is the data that occurs most often, which is going to be 260. All right, so there we have it on that one. So let's jump up to 17. Let's see, 17. For each 3 histograms, determine whether the mean is greater than, less than, or approximately equal to the median. Justify your answer. All right, so remember in class we discussed this. When data is symmetric, the mean, now we don't know if this is a population or sample, but it doesn't matter for this discussion. So let's use sample, so x bar and median are the same. I've got half my data above, half my data is below, and so that's where the median is there, and the average is the same thing. I've got the same weight of data over here above as below. Okay. Now what happens if I start taking data here and I start pulling it out this way? Well, the median is going to stay roughly the same, not roughly, it's going to stay the same, because I still have half of my data on this side. I still have 50% of my data, but the average starts getting pulled out this way because the data values get more and more if I start not adding, but pulling this data this way. So that's going to make this skewed more this way. All right? Or if I have outliers, outliers also make the average bigger. That's why you want really high test scores, or you don't want really low test scores. So on something like this, again, I don't know exactly what the mean and median are, but I do know that the median is going to be here, but the mean is going to be pulled further to the right, because these guys are going to make the mean much bigger. Another way to think of it is, what happens if I take these outliers here and I move them right here and stack them right on top of each other? Well, the mean just gets pushed back, but the median doesn't move at all. So these outliers greatly affect the mean, but not the median. So for this guy, I've got x bar is greater than the median, x bar equals the median, and here for the same reason, I've got the median somewhere in here. I don't know exactly where it is, but these lower numbers are going to kind of pull the x bar this way a little bit. I don't know how much, but we just know it's going to tend to pull it that way. So I'm going to have x bar is less than the median. Okay, so there we have that guy. And 18 is something similar. Match the histograms to the summary statistics. Well, I know if the mean and the median are the same or close to the same, it's going to be pretty symmetric. Okay, so I've got 2 symmetric diagrams. So let's look at this. It looks like the middle here is between 38 and 50, 39, low 40s maybe. This one, the middle, is going to be around 30. So this one looks like 30, 32. So this looks like it's going to be 4. And this one's going to be 1. Because the mean and the median are the same. And if it's skewed to the right, that means I'm going to have the median and the mean to the right. So which one has a bigger mean? So median is 26 roughly, and the mean is 31. Okay, so I drew it further than it showed. So they're saying the mean is over here somewhere. So that would be 3. And then this would be, the median would be on this guy 36. And then the average would be 31, a little bit smaller, so x bar, because the mean's going to get pulled that way. All right, does that make sense? 2. Okay, so they were good on that. So that's a short one, but got them all covered, I hope. Make sure you ask me questions if you got any, don't understand it.